Okay, so here now we are looking at a combination of the last little few lessons that we've done, and it's called solving linear equations. Actually, it's not solving linear equations. An equation has an equal sign in it, and when you look at this does not have an equal sign in it. I'm not saying that x plus 3 is equal to 5. This is telling me that x plus 3 is less than 5. So it's not equal, it's not an equation, it's an inequality. Remember, inequalities are things with the greater than, less than signs. So sorry if you have to erase the title. I did it on purpose, just to let you know. Honestly, I did. An inequality, it tells you that one side is not equal to the other side, and one is greater than or less than or equal to the other side. So how do you solve something like this? It's pretty much the exact same stuff that you've learned from before, just with a little tweak to it. So usually when you're given an inequality to deal with, you're told to do three things with the inequality. To solve the inequality, graph it, and then check it. Solving you've done before. It's the same thing. You don't get the letter by itself. Graphing, we just learned how to do that in the last lesson. Graphing inequalities, okay? And checking is just a little thing that we have done here and there. It's just, we'll do it formally now. So just like when you were solving equations, you have something like this. X plus 3 is less than 5. We want to figure out what could x be. So to figure that out, the rule is we have the letter by itself. Get the letter by itself. Right now the letter is being bugged by the plus 3. So we subtract 3 from this side, subtract 3 from the other side. You have to be equal. What you do there, or fair. And these plus and minus 3's cancel out. You're left with x on this side, and then the greater than sign, or less than sign in this case, and then 5 minus 3 is 2. That's stuff you've done before. So we've solved it. The inequality is satisfied when, how do you read this? When x is less than 2. So that's the solving part done. Now let's do the graphing part. How do you graph this? Well, you know how to do this. You make your little number line. Let's put 2 in the middle there somewhere. And we're saying that x has to be less than 2. This works only when x is less than 2. So can it be 2? No, so we have to do the open dot. And any numbers less than 2, I should use a different color when I do this so it stands out more. Any number less than 2 works. Okay, so this inequality is true for any number less than 2. And if you don't believe me, check it. So the graphing we just did, now let's check it. And to check this, let's see if we're right. Is this statement true for any number less than 2? Now for the check part, you get some freedom here. You can pick any number you want that's less than 2. Pick any number you like. Let's pick 1. Check for 1. Because 1 is less than 2. You could pick 0, you could pick negative 95, negative whatever you want. So for the checking part, you're allowed to pick any number that is, we say it is on the graph. In this case, we're saying it's less than 2, so you pick any number less than 2. Don't pick 10. That's greater than 2. And this is, we're talking about being less than 2. Okay, you can't pick totally any number, but you can pick any number that we think satisfies this inequality. So to check, all you do is you take the original equation, x plus 3 less than 5, and we sub in, wherever you see an x, you're going to sub in the 1. So we put a 1 in here. And remember, whenever you sub in something, it's a good habit to put it in brackets. And now we just do it. This side is 1 plus 3. It's 4. That's it. And that goes there. That just comes down. Is this true? Is 4 less than 5? Yes, it is. You didn't know? So we know we're right. The textbook tells you that you should pick 3 numbers to check from. 0 is a common one that people use really quickly. So you can check for 0 as well, or any other numbers that's less than 2 in this case. So you put a 0 in there. If you put a 0 in there, 0 plus 3 is 3. Is 3 less than 5? Yes, it is. And you can even check for, again, the book says pick 3. Let's pick a really small number, like negative 10. Let's put negative 10 in here. And that means that'll change this answer here then, right? Negative 10 plus 3 is negative 7. And is negative 7 less than 5? Yes, it is. So I know I'm right. I've solved it. I've graphed it. I've checked it 3 times, although I'm only going to make you check it once. With any 3 or 1 random number below or that satisfies the inequality, this is right. So that's solving, graphing, checking. Done, done, done. Okay, how about this one here? X minus 7 is greater than or equal to 12. Let's solve it. You can get the letter by itself. How do you get rid of it? Get it by itself. What's being bugged by this minus 7? Do the opposite. Add 7, add 7. 7's go away. You're left with just x, which is greater than or equal to 12 plus 7, which is 19. So we've solved it. And always first step is to solve it, which we just did. Now let's graph it. And to graph it, we just do the little inequality, the line graph. Let's put 19 there in the middle. And we're saying that x has to be greater than, because the mouth is going that way, greater than or equal to 19. So first tell me, is it going to be a hollow dot or a solid dot? Could it be 19? Well, x could be equal to 19. That's what that little half equal sign there says. So we would shade in the 19. I said I would do this in red. Shade in the 19, and anything greater than that, it could be 19 or greater, works. So there's the graphed inequality. That's all you gotta do. Graphing is done. Now let's check it. And when we check this, I'm gonna need more space. When we check this, so we can pick any number that we think it could be greater than 19. Pick any number greater than 19. Let's be wild and crazy and pick a number like 20. Ooh, that's greater than 19. So let's put 20 into this equation and see if it works. Or sorry, inequality, and see if it works. We put 20 into x and see if it works. So I rewrite the equation. X minus 7 greater than or equal to 12. I sub a 20 in for x. 20 goes in here. Minus 7 greater than or equal to 12. 20 minus 7 is 13. Greater than or equal to 12. Is that true? Is 13 greater than or equal to 12? It's greater than. So it works. Done. Solved. Graphed. Checked. Finished. How about this? 7a is less than 12. Okay. Actually, sorry. This is upside down. Or backwards. It's supposed to 21. Okay. 7 times a is less than 21. Well, what do you got to do here? What's bugging the letter? The letter's being bugged by the 7. What is the 7 doing to the letter? It's multiplying it. What's the opposite of multiplying? Dividing. I hope if you're weak on the algebra, then that means you didn't watch the previous videos properly. Go back and watch them. You've got to know your basic algebra. So we're going to divide by 7 on this side. Do the same to the other side. The 7's cancel out. You're left with a is less than 21 divided by 7, which is 3. Let me graph it. Put 3 there. Is it a hollow dot or a solid dot? Well, it's not equal to. It's just saying that a has less than 3. So it can't be 3. It's just less than it. Alright, so there's the solving, there's the graphing, and then the checking. You take, again, any number, pick any number that you want that's less than 3. So let's check for 0. That's less than 3. Let's see if it works. So we take our original equation, which was 7a less than 21. So 7a less than 21. And we sub a 0 in for our letter A. So 7 times 0, which is 0. And is 0 less than 12? Yes, sirree, Bob, it is. I know I'm right. Again, the book asks you to do it 3 times, which is a good idea, but I'm not going to do it here because it's going to take too much time. Alright, so how about this? Don't freak out. You've done these equations before. Okay? It's just because this thing is there, that just means you have to graph it and all that stuff with it. But again, we're getting the letter by itself. It's being bugged by this 2, which is multiplying it, and this 3, which is adding it. And like I had told you before, we do reverse BEDMAS, SAMDEB, when you get to things like this. Because you could have, SAMDEB, you could get rid of the 2 first or get rid of the 3 first. It's better to get rid of what's subtracting or adding first. Get rid of this first. Minus 3, minus 3. If you want to be stubborn and get rid of the 2, go ahead. You're going to run into some problems, though, I bet you. Get rid of the adding, subtracting thing first, which we did. Minus 3, minus 3. The 3's are gone. You're left with 2x greater than or equal to negative 7 minus 3. You're down 7. You're down 3. You're down 10. Now the 2 is bugging the x by multiplying it. How do you get rid of the 2 then? Divide by 2, divide by 2. X becomes greater than or equal negative 10 divided by 2. Signs are different. Negative 5 is our solved inequality. Then we graph it. When we graph it, put the negative 5 here. Now, is it a hollow dot or a solid dot? Well, because it's greater than or equal to, that means it could be negative 5. So we shade in that it could be negative 5. You put a solid dot there. And we see that x is less than negative 5. So it's less than, goes this way, negative 5. So that's the graph. Now we check. Pick any number that's less than negative 5. Any number less than negative 5. Let's pick, I don't know, negative 6. Negative 6 is less than negative 5. So let's check for negative 6. We had our inequality. 2x plus 3 greater than or less than or equal to negative 7. We plug negative 6 into here. This is why I tell you to put brackets around it. Because if you didn't, you'd think it was 2 minus 6, but actually it means 2 times negative 6 plus 3 greater than or equal to negative 7. That times that is negative 12. Plus 3 greater than or equal to negative 7. And negative 12 plus 3, you're down 12, then you're up 3, you're down 9. Is this true? Is negative 7 greater than or equal to negative 9? Yes, it is. I'm right. Again, if you're stuck, numbers more to the left on the number line or smaller. Shouldn't have had to tell you that, but whatever. Okay, now let's check out this one here. Negative 6 times x greater than or equal to 18. What's bugging the x? The negative 6. Now, what is the negative 6 doing to the x? It's multiplying it, right? It's not, people are so tempted to go, oh, negative 6 plus 6. No. What is the number doing to the variable? That's what you got to do the opposite of to get rid of it. It's multiplying here. There's nothing in between, it means multiply. Negative 6 times x, we get rid of it by dividing by negative 6. Dividing by negative 6. The negative 6's are gone. Now you're left with x is greater than or equal to 18 divided by negative 6, negative 3. That's our solved inequality. Then we graph it. Actually, you know what I'm going to do for this one? I'm going to skip the graphing just for a second, and I'm going to jump right to the check. Let's check to see if this is true. So let's check. So we have to check for any number that is greater than negative 3. X is greater than or equal to negative 3. So let's put 1. 1 is greater than negative 3. So let's check with 1. Check for 1. Our original equation again was negative 6x greater than or equal to 18. If we put a 1 into here, negative 6 times 1, negative 6 times 1 is negative 6, greater than or equal to 18. Is that true? Oh my God. No, it's not. It's not true. Negative 6 is not greater than 18. 18 is greater than. What's going on here? What just happened? That means this is not true. You thought they were all going to be true, didn't you? You thought this checking thing was a waste of time. This is not true. And that's because this question is a little something different to it. Whenever you divide or multiply by a negative number in an inequality, something weird happens, and the sign does not work. So what you have to do, so when you're multiplying or dividing a number by a value, you need to switch the sign. So whenever you multiply or divide by a negative number, the sign needs to switch. The inequality needs to switch. So let's rewind this. Well, I will rewind it. Don't worry about you rewinding it. And show how it was supposed to look in the beginning. So now that we know this little rule, let's do it from the beginning. Negative 6, we're going to divide by negative 6. I remember something about dividing by negative 6. When you divide by a negative number or multiply by a negative number, you have to switch the signs. I shouldn't call it signs. The inequality switches. The inequality switches. That means the greater than, less than sign switches. Okay? So, that still becomes just x, but instead of being greater than equal to, we're going to switch the sign. Switcheroo. The inequality. I should not call it sign, I should call it inequality. To make it go that way, 18 divided by negative 6, still negative 3, just the sign has been switched now. That's important. Okay, now we can, so that's solved. We can graph it freely now. Negative 3. It's because it's equal to. It could be x is less than or equal to negative 3. That means we would use a solid dot. X is less than or equal to, so that means anywhere this along that direction. And then we do the check. Anything less than negative 3. Let's pick negative 5, I guess. Okay, so let's check for 5. Actually, check with negative 5, not check for. So we read our original equation, 6x, negative 6x, greater than equal to 18. We sub a negative 5 into here, so negative 6. And then whatever we're subbing in, put it in brackets, negative 5. Negative 6 times negative 5 is positive 30. Is that greater than or equal to 18? Yep, it is. Now it's good. So that's a big one. Whenever you notice that you're about to divide or multiply something by a negative number, slam on the brakes. You got to change the inequality sign to the other direction or else it won't work. How about this? X is being bugged by the plus 8 and then negative 5. So let's get rid of the plus 8 first. Remember Sam Deb? Get rid of the plus 8 first by minusing 8. Minus 8. The 8's are gone. You're left with negative 5x. 23 minus 8 is 15. And now we're going to, the x is being bugged by the negative 5 because the negative 5 is multiplying it. So we divide by negative 5. Oh! I said divide by negative 5. The alarm bell should go off. When dividing or multiplying by a negative number, the inequality thingy switches. Okay, so that means, I guess we can first cancel this. We're left with x. Now the sign needs to switch. We got a switcheroo here because we divided by a negative number. 15 divided by negative 5 is negative 3. Solved it. We graph it. Put the negative 3 there. Does it need a hollow dot or solid dot? Well, it's saying that x is less than negative 3. So we know we can go this way. Less than negative 3. Is it solid or hollow? It's going to be a hollow dot because it's not less than or equal to. There's no line underneath, so it cannot be negative 3. So we do a hollow dot like that. Okay. So, when do you need to switch this inequality? Only when you have to multiply or divide by a negative number. So in your steps, you got to kind of be aware if you are dividing or multiplying by a negative number during your steps. Slam on the brakes, switch the sign. Okay, how about this one here? We've done these before, variables on the both sides. You have an x there and an x there. And like I said in that previous video, what happens when you have variables on both sides? Get rid of one of them. Who do you get rid of? Pick on the small one. 4x is less than 5x. So let's get rid of this 4x. How do you get rid of it? Well, you subtract the entire thing. Subtract the 4 and the x. Subtract 4x, subtract 4x. That's gone. You're left with just 8, which is greater than 5 minus 4x is just x. If you feel better by putting the imaginary 1 there, go ahead. Minus 11. And now the x is on this side. Who cares? It's still being bugged by this 11 that is subtracting it. Do the opposite of subtracting. Add 11. Add 11. This becomes 19. 11's go bye-bye. And you're left with 19 is greater than x, or x is less than 19. You graph it. There's no equal sign there, so 19 gets the hollow dot. And x is less than. This inequality works for whenever the values are less than 19. Okay. And you would do the exact same check and figure it out. This one here, negative x divided by 2, greater than or equal to 2. Well, this x is being bugged by this negative sign of the 2. What I suggest you do is get rid of this. How do you get rid of the divided by 2? You get times by 2. You're dividing by 2. The opposite is timesing by 2. So you times this side by 2, times that side by 2. These 2's cancel out. You're left with negative x greater than or equal to 2 times 2, which is 4. Now in a previous video, do you remember what you do with the negative x? There's the cheap, dirty, simple way, the sign switcher way, or in the previous videos I showed you that this is actually, there's an imaginary 1 in front of every variable. So to get rid of this negative 1, which has appeared now, how do you get rid of negative 1 multiplying by x? You divide by negative 1. Oh, did I just say divide by negative 1? That's the alarm that goes off. And we're dividing by a negative. Or when you're multiplying by a negative, you got to switch the inequality sign. So we divide by a negative. The negatives cancel out. Negative 1's cancel out. You're left with x. And then we're going to switch the sign. We got a switcheroo because we divided by a negative number. So we switch. This goes that way. 4 divided by negative 1 is negative 4. There you go. And graphing, yeah, you know what to do there. And checking, yeah, you know what to do. All right. Here are your skill testing questions. For each one, you need to solve it, graph it, and check it. Each one gets the full meal deal treatment. And you only have to check with one number. All right, hopefully that worked out well for you. Thank you. Bye-bye.